Angular is a framework for building client applications in HTML and TypeScript. Plain JavaScript can be used, but part of the awesomeness of Angular, and what sets it apart from many other JavaScript frameworks, is that everything can be written in TypeScript. We won't go into the details of TypeScript now, but know that it is a much better language for writing web applications as compared to JavaScript, and that it is ultimately compiled to JavaScript so it can run in the browser, which doesn't understand TypeScript. The Angular framework is made up of several libraries. Some of those libraries are part of Angular's core, and many are optional. Angular applications are created by writing HTML templates with Angularized markup, and then adding component classes which back those templates, or manage them as it were, then rounding out the functionality of those components with application logic encapsulated in services. Finally, all of these elements are conceptually arranged within modules to logically box out the related features or domains that make up an application's specifications. Angular applications are launched by bootstrapping the designated root module. Upon bootstrap, the Angular framework takes control and presents the application's initial content in the browser and responds to the user's interactions according to the application's design, which we provide in our template, component, and service code. This is a high-level description of how things go down in Angular. We need to see things from this level and then dive deeper into the details, which we will begin doing now. This architecture diagram identifies the 8 main building blocks of an Angular application. Components, which include metadata, templates, directives, and data binding, routing, services, modules, styling, and dependency injection. These are the foundational concepts we'll be focusing on in this course so we can understand the architecture of the Angular framework and use it to design and develop applications effectively and efficiently. Let's work our way backwards through a running Angular application, from the application's views rendered in the browser, where the user is clicking and consuming, back through the JavaScript code behind the rendered pages, back to the data that was handed down from a REST service, all the way back to the application scope itself. First, the pages or views the user is seeing and acting upon are in Angular rendered templates, one of the component's metadata items. Templates are HTML files that render a page's contents and a component's properties. For the most part, a template file is a bunch of HTML. Angular is defined by its ability to mark up HTML in the browser with its amazing features and transform the DOM. There are 2 ways those amazing features are actually woven into a template's HTML. The first is a concept called directives, another one of the component's metadata items. Directives tell the DOM how to transform. For us, as Angular developers, directives are classes with the directive decorator applied with associated metadata. But for the browser, directives are things inserted into HTML element tags, like the way attributes are inserted. Structural directives directly change the layout of a page. They can add, delete, and replace DOM elements. A common usage is a conditional where an element should be displayed only if a certain condition exists. Another well-used structural directive is for iteration, when building a list on a page. Attribute directives work directly on HTML elements already in the HTML. Style or class attributes can be added to HTML elements with attribute directives. Data binding and event sensitivity can be applied as well. The second way to weave amazing features into the template's HTML is with components, which actually are directives. Yes, they're directives with a template of their own, and that template is the one we're weaving these amazing features into. Components have properties that can be bound to the template's HTML elements. For instance, a component may have a first name property defined within its class. The component's template then can have an input box that is directly bound to the class's property and display it by default and change it when the user types into the input box. Binding is coded with the double mustache syntax or with a special syntax of certain structural and attribute directives. One property on a component's metadata is its selector. This value is used in HTML to place the component's template onto the page in a particular place. The HTML syntax used is the same as normal HTML element tags with an open and close tag. With mention of data binding, the component property to HTML input box example that we just went through explains the concept pretty well. The most direct way to put data into the HTML template, though, is with interpolation. This is the double mustache syntax we talked about with the name of the component property. This is an example of one-way data binding, which means the data is displayed on the page in read-only mode. The displayed data will be refreshed only if the property changes programmatically in the component. Two-way data binding is achieved in the component property to input box example we spoke about. Two-way binding allows manipulation of the defined component property either by logic within the component class itself, like one-way data binding, or within the template, for example, by the user directly typing in the input box. The data changes flow both ways, app to browser, or vice versa. Metadata in terms of Angular, as we've been building up with all of the descriptions of the component's descriptive properties thus far, is formally defined as the properties of a class's decorator. Decorators are functions that modify JavaScript classes. Angular has many decorators that attach metadata to classes so that it knows what those classes mean and how they should work. As we've seen, metadata for a component's decorator includes the CSS selector string for referencing the component in HTML, any used directives, and its associated template. Many classes are adorned with decorators, and there are many to choose from in Angular. Each defined decorator includes metadata which defines the functionality of the class it's annotating, or extending as it were, and another metadata property is providers, which brings us to services. In Angular, a service is a JavaScript function, or class, that is available for and limited to an Angular application and is responsible for doing a specific task. Angular services are substitutable objects that are wired together using dependency injection. We can use services to organize and share code across an application. Angular services are lazily instantiated. Angular will only instantiate a service when an application component depends on it. Angular has built-in services, and custom services can easily be created and implemented in an application. Typically, custom services are built to provide data to a component. A widely used built-in service is the HTTP service, which reaches out to the server and returns a workable response. Another is the timeout service, which provides countdowns for appropriate functionality within a component. Services, as mentioned previously, are provided in a component and are injected into the component when called by the Angular dependency injection framework. The providers metadata element takes an array of services as its value, and each of the defined services is lazily loaded or injected into the component when it's needed. Speaking of injection, Angular has a built-in dependency injection framework, which is loaded when an application bootstraps. As mentioned above, services are classes that are wired together using dependency injection, but no class can be a service unless it's registered with an Angular injector. This registration is done by referencing the class in a module or component's provider property. We'll dig into these details as we get further into the guts of components. Of course, styling is a notable aspect of an application's design. Styling is addressed in many different contexts within an Angular application, but can be corralled for the most part by introducing a styling library, which is applied at the application context and is used by all child components. Then, at the component's template context, one-off modifications can be applied to supplement the handed-down styles.